Well, good afternoon, everybody. Very warm welcome to Bite-Sized Corrosion. Believe it or not, this is the 31st edition of our Bite-Sized Corrosion series that has been presented by Isifundi Training. So I'm wearing a slightly different hat today. My name is not Vanessa Sealy-Fisher. I'm Neil Webb, as many of you will know. So today we have our normal host as the person on the other side of the microphone. And Vanessa is going to be talking to us on the subject of theft and vandalism in the cathodic protection industry, having just presented this topic at a recent conference in CEOCOR in Europe. And there's been some interesting feedback that has come from that presentation. So in the series, as I said, we're going to be looking at theft and vandalism as a subject. And I'm welcoming Vanessa Sealy-Fisher to the microphone on the other side of the desk. So welcome, Vanessa.
Thanks, and thanks for having me today.
Just to set the stage on the subject and to get an overview of the situation, cathodic protection and AC interference mitigation are two highly specialized technologies that span the divide between electricity and chemistry, and yet we apply these to civil and mechanical engineering related infrastructure. And so there's a real mix-up. This is the so-called built environment in modern parlance. What is it about these industries that makes them so vulnerable and such attractive targets to the purveyors, if I can call them that, of theft and vandalism?
Well, thank you, Neil. I think that's a very valid question, is looking at why, what is so appealing. And I think we need to think about what the major components of the traditional cathodic protection system are. We're talking about a transformer rectifier, we're talking about copper cabling, we're talking about perhaps some brick structures, and all of those from a theft and vandalism side have the possibility for reuse. So from a South African perspective, I think when we speak vandalism, we actually mean theft, I think. But I think that they all have economic value and they can all be reused. So even if they're not stolen for financial gain, they might be stolen because they can be used to get power to somewhere that doesn't at this stage have power because now they've got some extra cable, that sort of perspective.
But you were saying that in South Africa, we look at it primarily from a theft point of view. Is this unique to South Africa?
I was actually very interested to discover it isn't. I think as South Africans, we often like to think that our problems are uniquely ours, and we are unique as South Africans, and I own that. But as I was exploring the whole concept of theft and vandalism, this is not something unique in the cathodic protection industry here at all, but the manifestation is different. So throughout, we can call it largely first world countries, there's a lot of vandalism of infrastructure which appears to be due to boredom, delinquency, lots of spray painting, damage for damage's sake, that sort of real vandalism. But in countries such as Nigeria, Mexico, South Africa, there was lots of documented evidence of vandalism, as we call it vandalism, but which is actually theft related. And those countries are all countries with economic issues, which I think is why we see it as a theft and vandalism component like we experience here.
The theft of electric cables is a scourge that we're all too familiar with. We see it in terms of power interruptions and things like that. But when we look at that, we've seen that because of this issue in, for example, the unreliability of maybe telecommunications, we've seen the development of fiber optics, where now the communication system is still functional, but the material that is used has no scrap value. It has no resale value. Do you think there's any room for that sort of approach in the cathodic protection industry?
Well, when the electrical engineers design a fiber cable that can carry electrons, I think we'll all be rejoicing. That would be fantastic, but practically that doesn't occur. But yes, we have seen some changes in thinking to try and make the copper appeal less prevalent. So copper is very definitely the component that appears largely to be the very first thing that's targeted. It has very high resale value. It's usually quite easy to strip out, and there's a known win factor from the thief or the vandal perspective. They know that if they dig up the cable and they strip off the PVC, they're going to have copper, and that has high resale value. There was some research done into a cable that took a stainless steel coring and combined it with copper in a manner that made it very difficult to extract the pure copper out, but increased the electricity carrying capabilities of the cable. The trademark name was Kwena, Kwena. It was very popular for a time. I haven't seen it around as much in the last few years. It was very popular just before COVID. Now, whether COVID scuppered it, I actually haven't done any research, but that was very definitely a deterrent, except there's always still the first vandal experience. So you use Kwena cable in your installations, there will still be vandalism to find the cable. The first cable they dig up, they go, oh, this isn't copper. They might do it again, they go, it still isn't copper, and then give up. And then to an extent, quote, you've won. And then obviously from an infrastructure point of view, the rectifiers are also easy pickings for copper. Lots of cables, lots of copper in them. And the increasing prevalence of the switch mode, little magic box rectifier has definitely decreased that. Again, one or two get vandalized, and then the news seems to spread that don't waste your time, there's nothing in these worth stealing. So I think those have been two bits of hardware that the scrap value can be diminished. But yeah, it's difficult. And as I say, we're still trying to move electricity around, and we haven't found a use for. I mean, we could use gold, but that might be even more attractive.
Yeah, right. The challenge of this material being stolen, is it related to the location of the installations, or is it universal?
I think that's also a very valid question. I think there's definitely areas of great need, great poverty, tremendous unemployment. You'll definitely see more vandalism. I know there's an increasing perspective from the design sort of point of view to see if we can't locate the equipment in greater secure areas. I mean, I look back over the past 30 odd years, and I think, we thought security was a concrete palisade fence, and then that was breached. And then we thought security was a concrete enclosure for the rectifier, and then that was breached. So I have to say that it stretches us. We're now looking for a more secure place to put the equipment. Buried, I know that there have been numerous trials. When I was doing some research on this, it was interesting. There were some studies in Mexico, and they had these really fancy buried oil-cooled rectifiers, high output. The housing was incredible. It was like building a below-ground house to put these rectifiers into, with complex mechanisms to open them. And of course, that also becomes another challenge, because then if things go wrong, you can't get in easily. But they can also, once it is seen, it can also be breached. But we could try and place the equipment in a secure area, but practically when you do the design, you need to think about why you're putting in the equipment anyway. Why do we want cathodic protection? We wanted to protect stuff that's our pipelines that's in a corrosive environment, and that's usually low-lying. And we don't usually build our secure infrastructure in low-lying areas because of flooding. So yes, that becomes a little bit of a challenge. And of course, we can't turn off the stray currents. So the rails go where the rails go. And we know that in South Africa, the railway network itself is beset with theft and vandalism challenges. But there is still stray current interference associated with the rail networks. And a good designer will know that you can't place the rectifier where it suits you, but you have to do it where it suits the electricity, because it chooses its own path. And so that also becomes difficult in terms of placing the equipment in secure locations. So yeah, I think there's also the concept of how far the current will spread. So, wouldn't it be lovely if we could put a transformer rectifier at the start of a 300-kilometer pipeline in the secure water treatment facility, but it's not going to spread the whole 300 kilometers. So I think we're constrained by the limits of the cathodic protection system and its design. But I do also think that it is challenging us to be creative and look for new ways and design better systems. I think it's a challenge, maybe not one we always appreciate at the time.
It's one thing to look at improving the equipment itself or the location of the equipment, but what can we do on the pipelines themselves to facilitate more vandal-resistant installations? I mean, long time past, many of our pipelines were coated with bitumen-based systems, and they had relatively high current demand, and so you needed lots of amps and at relatively close spacings. But these days we've got a plethora of new coating materials that can be applied. Does this give us greater freedom in terms of the designs that we use in terms of cathodic protection in order to alleviate the challenges?
Yeah, I think so. I think we, as in every field, there's a lot of legacy that we do because it's always been done. So one of the challenges with vandalism is immensely frustrating is the vandalism of test posts. So traditionally, test posts on a water pipeline are every 500 meters. And when you say, well, why? And you go back and you say, well, that's where valve chambers were, and that seemed a convenient location. And then you go, why? And that's because that's how the really old valves worked. And my understanding is that valves no longer need to be installed at 500 meters, but a lot of this has just become legacy, and it's just sort of, that's the way it always was. So I think if we look at the pipeline itself, yes, the transformer rectifier is one aspect, its location. We need less current. So we could be looking at other mechanisms of getting reduced current, smaller rectifiers, switch mode rectifiers that are more of a little box than these big units. We can look at sacrificial anodes. That's from the current supply side. We want to measure what's going on. I think remote monitoring is something that definitely could be used. I think that may also be prone to vandalism because you still need something in these remote locations. Test posts, I mean, we've seen some phenomenal ingenuity in test posts. The typical American test post is a little plastic tube sticking out of the ground with a plastic cover. I mean, that really doesn't stand a chance. They upgraded in this country, moving to galvanized test posts. They started being vandalized. They changed the key system. That was vandalized. We've had lots of ingenious bunkers, concrete bunkers, which some of them have been, called things like the AK-47, because we were trying to withstand the impact by the vandalism sector. And so thick concrete walls, tiny access, difficult access, all to minimize somebody getting inside and quite frankly stealing 100 rands worth of copper. I mean, that's really the tragedy is we've been evolving these very fancy things. There are new test posts being developed all the time. For many, many years, I dreamt of the day that they'd put test posts on a flagstone. I remember very early on, and actually it wasn't because of vandalism, I saw a test post being taken out. I think it was in Sasolburg by a truck turning a corner. And I thought, well, if this was at ground level, it wouldn't be at risk. And not being an engineer myself, I kind of had the idea, but had no idea how to practically implement it. And now, floor level or ground level test posts are being used, which I think the more that you hide something in plain sight, the better. I joked with someone, in fact, the late John Hay from Cathodic Corrosion Control, about 2 months ago, we were actually joking about some infrastructure that he was developing. And I said to him, before it even leaves your yard, just paste it with some of those adverts, call this number 083 da 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 for, free this or whatever those adverts that get plucked on everything. And we joked that if he installed it already laden with adverts, nobody would even notice the infrastructure was there. And I think sometimes, hidden in plain sight is a real thing we could look at.
The infrastructure side of it is one thing. What about going back to the future in some ways? What about going to sacrificial anodes instead of impressed current systems with all their electrical hardware that is so readily recyclable. Can you put in a sacrificial anode system on a long-distance pipeline?
I think you can. You're the design engineer who should answer that more than I can. But from my perspective, I think having seen the evolution of coatings to these high insulation value coatings that have a very low current demand, and in general, better installation, field joints, the current demand of the pipelines is really low. Jokingly, one says, you could use a little 9-volt battery. And maybe we'll get to a way that we do that practically. But I think sacrificial anodes are definitely something that should be explored more. I think there are concerns with them. I think there are challenges when you're dealing with interference. So that is, but definitely a sacrificial anode, you don't need to see it at all. You connect it directly to the pipe and that's buried. And there should be or could be a situation where there's nothing above ground that tells you that anything's there, especially with sub-meter accurate GPS in these days. I do think that's a practical solution. And I also think we need to be careful though, because that fabulously low demand for CP comes at a cost of the high challenges with high AC interference, with exactly the same coating. But we often use, again, sacrificial anodes to earth the AC off the lines. So again, I think we can start to push the designers to be creative, to put the two systems together to feed one off the other, maybe using the AC to be the CP. I think there are ways to play. I can think of ideas, but I can't necessarily implement them. But I think there are ideas that could be implemented. But sacrificial anode CP is definitely something that is being used increasingly. And quite controversially, don't use a steel pipeline. I mean, that takes away the need for the cathodic protection.
Well, the day when you can push hydrogen through a plastic pipe at 200 bar, it'll be quite some plastic.
Well, yes, there's that.
But going back to the sacrificial anode side, there's a slightly amusing, it's amusing in retrospect. It was not at all amusing at the time. It's a situation that occurred in a fairly remote pipeline along the coast in East Africa. And the system was designed with sacrificial anodes because there was no power along the route of the pipeline and because there was the challenge of AC interference. So we combined the AC and the CP into a single system, installed it, and we discovered that this was being dug up and stripped out pretty much as fast as we put it in the ground. And we discovered that the local inhabitants were using the zinc wire electrodes, ribbon electrodes, as a raw material source for making fishing weights.
Neil, I do think that particularly in poorer countries, particularly here in Southern Africa, where the theft and vandalism is largely a socio-economic and probably socio-politico-economic issue. And when you're dealing with impoverished communities who see the infrastructure there that could give them some sort of income, even temporarily, or be of use so that they can feed themselves, they don't appreciate what the vandalism could result in. And I think very often we don't think that through either. And in fact, on one project that we were involved in, we were, as fast as we were replacing the chest posts, they were being vandalized. And at one point, I remember saying to some of my colleagues, for goodness sake, can we not put a stack of 100 Rand notes in there? Because they were literally only getting 100 Rand at the time for the copper. And the cost to replace at that stage was about 8,000 or 10,000. And I was going, we could put 100 Rands inside these test posts and say, please don't vandalize it. Just take 100 Rand and go and buy yourself food for the day kind of thing. Because that's the reality, is the vandalism is largely there. I don't think it's, I may be completely naive, but I don't think it's syndicated. I think it's local communities in need. And that becomes the socioeconomic situation and increase the work, increase the economy within that sector, and we probably find it reduced. So Yeah, I think it's a bit of a head scratcher, and maybe dishing out fishing weights whilst laying the anodes might have resolved the problem in East Africa. I don't know. I think we need to put our heads together on more than just an engineering, because it's not an engineering problem. It's bigger than an engineering. I mean, there is an engineering problem, but it's bigger than that. And we could get quite philosophical about it. But I think somehow we need to find a way of engaging. I don't know whether it's with the communities or with government or leadership or something, to see if there's a way around it. Because, yeah, as I say, I don't think vandalism here in South Africa is largely vandalism for vandalism's sake. Although I will say, sort of as closing, which completely contradicts what I've said, we've got a situation on one of the projects that we work on where the test posts and rectifier bunkers have clearly been used for target practice. They literally have painted things onto the various concrete structures and used them as target practice, and they're riddled with bullet holes. Now, that is more of the vandalism for vandalism's sake, for target practice sake, and in those situations, there has been no theft. It's literally just destruction. But in general, I think we deal with theft here. Yeah.
I think one of the considerations that the infrastructure owners need to give is perhaps better community involvement, so that you get buy-in from the community in terms of the upkeep and operation of a pipeline, for example. Clearing the servitude, give them some sort of ownership over this intruder, instead of saying, well, this is ours, leave it alone, stay away, and so on.
No, definitely. And I've always said, if you can get the gogos involved, the grandmothers within the communities, you're probably on a winning side, because those ladies are often very proud of their community and they don't want any scavengers or vandals associated with them, and they can often keep it well in check. But yes, I think you're right. Community involvement is probably the way to go, and more explanation rather than dictation as to how the process works might be more engaging and more successful.
I think that's probably more relevant in water pipelines, perhaps, than fuel and gas lines. It more directly affects the community. Oh, Vanessa, thank you. This has really been an interesting discussion.
Thanks for having me today.